Good afternoon. The Zoom room is filling up. That must mean it is noon on Tuesday for our virtual speaker session. Welcome into the Zoom room, everybody. I'm Paul Clifford, CEO of the Penn State Alumni Association. Go ahead and tell us who you are and where you're from and your Penn State class year. You can do that by dropping all that information in the chat. Let us know where you're zooming in from today. We have a great program lined up for you. We're going to be talking with Jason Wright. He is the director of Penn State's Extraterrestrial Intelligence Center and is serving as the acting director for the Center for Exoplanets and Habitable Worlds. Looking forward to his presentation and a conversation with him in just a couple minutes. Welcome to the virtual speaker series. Again, welcome in. If you're just joining us, we're going to get started in just a minute. I see Lynn Marie DiCarlo from New Milford, New Jersey, and David from Harrisburg, class of 81. Shelley zooming in from Maryland. I see Barbara Gaston, Astronomy 82 from Eugene, Oregon. That is our former hometown. The Cliffords spent a couple years in Eugene and have a daughter who's studying at the University of Oregon. So good to see folks from the West Coast. I see Elizabeth from Denver, Colorado, and Amy Kingston, class of 09 from South Carolina. Mike right here in Happy Valley. Good to see you, Mike. Charlie and Schmoken, class of 81, and Bill in Allentown, class of 68. Oh yes, everyone's looking forward to the snowstorm that's coming here. I see Lilbeth from class of 98, welcome. And Guillermo Silva from San Juan, Puerto Rico, a member of Alumni Council, class of 90. Good to see you, Guillermo. And Dick Smith from Appalachian, New York, class of 65. And great, the Zoom room is full for this presentation, which we will be starting in just a moment. Thanks for tuning in to the virtual speaker series presented by the Penn State Alumni Association. Where else would you rather be than a Zoom full of Penn Staters? Good afternoon, and thank you for joining us. I'm Paul Clifford, CEO of the Penn State Alumni Association, and I'd like to welcome everybody to today's virtual speaker session, which is being recorded. Live closed captions are available for this event. You can access them by clicking the closed caption button at the bottom of the Zoom video window and then clicking Show Subtitle. You can also customize your caption view by clicking the Stream to Text link posted in the chat. This afternoon, we welcome Professor Jason Wright. He is the director of Penn State's Extraterrestrial Intelligence Center and serves as the acting director of the Center for Exoplanets and Habitable Worlds. He earned a PhD in astronomy and astrophysics at the University of California, Berkeley, working on problems of stellar astrophysics and discovery of planets orbiting other stars. Professor Wright joined the faculty at Penn State in 2009, where he maintains a research group that studies a variety of problems across stellar and exoplanetary astrophysics. He is the instrument team project scientist for the NEID spectrograph, a premier planet hunting instrument at the US National Observatories, but was built right here at Penn State. The modern search for extraterrestrial intelligence, the SETI, started around 1960 with the realization that humanity was capable of producing signals that we could detect at interstellar distances. A NASA program to detect radio waves from alien technology fought for funding through the 1980s before being canceled by Congress in 1993. Since then, SETI has limped along as a field outside of academia supported by private funding, but that has begun to change. This year, Penn State founded the new Extraterrestrial Intelligence Center, focusing on private philanthropy and changing political winds at NASA for support. Professor Wright will discuss the ambitions of the new center and some of the research happening right here at Penn State. I'm now going to turn it over to Professor Wright.
All right, great. Thanks, Paul. Yeah, I'm excited to share this all with you. It's things have moved really quickly in the last several months, and I'm really excited to be able to talk about everything we're doing. So let me get this share going here. I think you can all see that. Right, let me talk to you about the search for extraterrestrial intelligence and what we're doing here at Penn State about it. Now, when I say the search for extraterrestrial intelligence, if any image comes to mind, what you might think about, it might be this one, Jodie Foster with the headphones on and her laptop at the Very Large Array in Socorro, New Mexico, in the film Contact. This film, which is great, was written by Carl Sagan, or it was based on his book. And it is a really accurate description of how radio astronomers go about looking for life elsewhere in the universe. And except for the part where they actually find aliens, it's all basically true. And in fact, Jodie Foster's character is based on an actual astronomer, Jill Tarter, who has dedicated her whole career to this. So when I say SETI, I mean the search for extraterrestrial intelligence. And it's actually a much broader field than just radio. It's just asking the most profound question that we ask in science, which is, are we alone? Are there other species out there in the cosmos that think like us, that build technology like us, and that we could perhaps at some point even communicate with and contact across the stars? But if this is going to succeed, we're going to have to keep very open minds. We know that we can produce radio waves that we could detect at interstellar distances. That is, if we had a radio observatory at the nearest star, Alpha Centauri, we would be able to detect our own radio emissions from interplanetary radar. And so even with our technology, we know that we can be seen at interstellar distances. The question is, can other species be seen by us at those distances? But we can't assume that they're going to be using interplanetary radar or doing the sorts of things we do. So it's really going to require ingenuity. We don't know exactly what we're looking for. We have to keep very open minds. And that means we need a no stone unturned sort of approach. We need to think of every possible way that we might succeed and not stay too focused on just one thing, like, for instance, radio transmissions, which is a great way to look, but it's just one. And Penn State is really uniquely positioned to do this, of all the universities that could take this on. And for a lot of reasons that I'll describe, but this position's actually been endorsed by a lot of people. We have an advisory board for the Penn State Search for Extraterrestrial Intelligence Center that includes Alex Volschan, one of our faculty who actually discovered the first planets outside the solar system. It includes George Smoot, a Nobel laureate at UC Berkeley. It includes Frank Drake, who more than anyone could be called the father of the field. He really got the whole thing started in 1959. It includes President Barron, former Dean Doug Kavanagh of the Eberly College of Science, and a lot of other luminary scientists who all agree that this is a really good idea to do it here at Penn State. So I said that we have to get beyond just using radio waves, but that can be challenging. The atmosphere only allows us to explore the universe in a few ways. So this is a chart here. What you really need to know about it is that radio waves are way on the right of this chart, and things like gamma rays are way on the left. And the sort of light that you might be able to see with your eyes when you look up at the sky and look at stars, that's that green band on the left. And all of these other places, all of these things on top are different kinds of telescopes that can explore different wavelengths of light for astronomers. And what the atmospheric opacity is telling you is that the atmosphere just doesn't let most kinds of light through. Way on the left, gamma rays, we can't explore those because they don't get through the atmosphere. And then in the middle, it's all gray, that's infrared radiation, that doesn't get through the atmosphere. The radio, there are a lot of things there, different kinds of radio telescopes can explore signals very well. And then if you go even farther to very long wavelengths, we can't look again. So there's only a few ways we can actually explore the universe from the ground. And that's why most of this work to date has been done with radio telescopes and a little bit looking for lasers at visible wavelengths. But things have really changed since Frank started this in the 1960s. The biggest change is that we now understand that most stars have planets. And this was something Frank didn't know in 1960 when he started pointing his telescope at different stars to look for signs of life in the universe. He thought that most of the stars probably didn't have planets, and he'd have to get lucky to point at one that did. Part of the revolution that's occurred just in the last 10 or 20 years is this realization that most stars have planets, and that something like a quarter of them or more have planets that could potentially host life, like life on Earth. And so it was in the course of studying these planets around other stars near Earth that I sort of got involved in this whole thing for the first time. We noticed that one of these stars, we were looking for planets around it, and we saw that it had something around it, but we couldn't tell what it was. It definitely wasn't a planet. And it didn't conform to any theories of things that we thought should be around stars, but it did actually conform with some speculation about the kinds of things that alien technologies might look like orbiting other stars, giant space stations and things like that. And so we thought that was interesting, and we decided to take a closer look. A reporter at The Atlantic, Ross Anderson, got the scoop, published this article, so I encourage you to look up. It's a really nice article about our work. It became a big media sensation. It was on Saturday Night Live. It was in The Tonight Show. People got very excited about this star that we might have actually found alien life. The original suggestion when this star was first discovered is that it was surrounded by giant swarms of giant comets, which is probably correct. Our suggestion was that it was surrounded by something else. Here's a fanciful illustration I found on Google about the sort of something else that might be around it. Not, something that could really exist, but a neat little illustration. We worked on this star a lot. We eventually established that it's probably the interstellar comets. It's definitely not giant structures around the star. So that made the public a little less interested in it once we knew it wasn't aliens. It's still a really interesting object though, but it illustrated to me how much we can do to sort of look for this sort of life elsewhere in the universe. So this is Frank Drake with one of his famous equations trying to describe the prevalence of alien life in the galaxy. He remains, sort of revered as one of the leaders of the field. And here he is at a recent conference on the search for extraterrestrial intelligence at the SETI Institute in Mountain View, California. There he is right in the middle. And there's a few things to note about this conference. One is there's not a lot of people at this conference. As scientific conferences go, this is, it's not that large. And that's because this is a very small field. The other thing to note is that there's a lot of old guys. And that's because this is not a field that has had a lot of funding in it and hasn't had a lot of training. And the people that have worked on it are largely retired, and there just aren't that many of them. In fact, in the lower left there, Jill Tarter, she's the one that Jodie Foster's character was based on. There she is. She likes to joke that you could take all the people working full time on the search for extraterrestrial intelligence and fit them in a phone booth. And if you're really clever about the way you do things in phone booths, that's basically right. That's kind of the number of full-time people working on it. And the reason for that is Congress. NASA and the National Science Foundation should be funding this a lot. It's right up their alley. But in the 1990s and late 1980s, it became very popular among certain senators to grandstand about cutting the pork and cutting the fat and cutting the deficit and picking on small programs that didn't actually cost very much money as evidence that they were serious about this problem. And so Senator Bryan, for instance, boasted that he had ended Martian hunting at the taxpayer expense. And the result is that NASA and the NSF have almost completely refused to fund it ever since. And as a result, there hasn't been any training in it. It's all of the work that's been done has been through private philanthropy. And that means it's happened mostly outside of universities, and there hasn't been a lot of training. But the winds are changing. Something has shifted. Congress actually seems receptive to this line of research now, probably because we know about all those new planets. NASA's very big on finding life in the universe now. And so Congress has been pushing NASA to include this back in its portfolio. And in 2018, NASA actually held a workshop where they asked the astronomers that are still working on this field to come together and tell NASA how it could get back into the field. The problem was there was almost no one to talk to because there's so few people worked on it. And so they actually asked me to organize this conference and put it together. And instead of just asking, all of the people that had worked on it, we put together everyone that could work on it. We found everyone who was doing the sorts of things you would need to do to advance the field forward and have that conference. And that's why this one looks very different. It's bigger. There are students here, including 2 Penn State students there in the lower left. And it was a smashing success. And everyone there said, this is great. NASA might fund this again. We need to go forward. What are the next steps? So I think the next steps are for Penn State to take the lead on this. You might not know this, but we have the highest cited astronomy faculty in the world. Our astronomy department generates more citations to its papers than any set of faculty of any university. We're the only department in the world that has more than 1 scientific editor for the American Astronomical Society journals. There are only a few scientific editors, and we have 2. We teach the largest number of students astronomy in the country and maybe the world. Thousands of students learn astronomy every year at Penn State. We are the hub for multiple NASA missions, including the Swift Observatory. We also contributed one of the large cameras on the Chandra X-ray telescope. We're also the only place where you can get a PhD with SETI as part of the curriculum when you learn astronomy and astrobiology. And this is based on a graduate course that I teach here at the university. In fact, I have final papers in my inbox from this year's instance from the graduate students. We had 14 graduate students take this course, which is huge. It might be the largest graduate course we taught. There's a lot of interest in learning how to do this stuff. And Penn State is basically the only place that you can get that training as part of your PhD. Penn State also gets beyond just the radio and the optical. Penn State hosts AMON, which is a network of observatories in space and around the world that cover the entire electromagnetic spectrum and beyond. That means we have the Swift Observatory that collects gamma rays and X-rays and ultraviolet photons. There are telescopes that collect infrared photons. And then there are also neutrino observatories around the world. There are cosmic ray observatories around the world and gravitational wave observatories around the world. It's only in the last 10 years that we've had all of those observatories all linked together, observing the same phenomena at the same time. So we're no longer just restricted to looking in the radio. We can search every possible way and keep that open mind. So that's great, but the problem with that kind of approach is that you generate enormous amounts of data and you just cannot look at it all. But that's also why Penn State is the right place, because we have the Institute for Computational and Data Science, where we have an enormous supercomputer with huge amounts of data, and we have world experts on data science and how to tackle all of that astronomical data at once. So I'm really excited to have Penn State apply all of its talents to this problem and take the field forward, especially now that it looks like NASA will get back involved. We've already had some success building up funds for this effort. John and Natalie Patton have been wonderful benefactors. They contributed an estate pledge for a future gift of $2.5 million to get us started, which is just absolutely fantastic. And we're going to be able to use that money to create a world-class research program in this, but most importantly, also to train the next generation of researchers so that we have this big workforce that can work on the problem and compete for that NASA money. And so after their very generous pledge, we instantiated the Penn State Extraterrestrial Intelligence Center here at Penn State. And this has been a big deal. Science Magazine published an article about us, about how we'll be not just searching, but training students. The New Yorker actually profiled me in a really nice award-winning article about better ways to search for life in the universe. Scientific American was really impressed that there's going to be a graduate program where you can actually learn about this. And our students in that graduate program themselves are making waves. This is a Science Magazine article about all the different stuff going on. but you'll see the first 2 paragraphs in the article are about Sophia Sheikh, who will graduate next year from our PhD program. And I'm sure that she is going to be a leader in the field because she's already leading this field with amazing new ideas. And NASA seems to be making good on its pledge that it will fund this again. There have been some rounds of funding. It's always very hard to win. The success rates for these grants are like 10%, but we have managed to get one of those here at Penn State in a recent funding call. And so that's some money that we can use to do this research. So we've got some great students already doing this. This is Sophia, who I mentioned, that was led off that article. Her research has been featured in press releases. Here's one article at Vice about one of the projects that she did working with people at UC Berkeley. Shubham Kanodia was in the graduate class a couple years ago. His final project was so good, we wrote it up and published it. The Economist thought that was really cool, and they published an article about his research. And then we have a new generation of students coming up, since those 2 are going to be finishing up soon. This is Macy Houston and Nick Tassay, 2 first and second year students working with us on new projects that I'm really excited about. So it's really cool that this is all getting going. We're training the next generation of SETI practitioners. We're getting new strategies and technologies that haven't been tried before. We're really trying to foster a whole worldwide SETI community. We don't want to keep it here at Penn State. We want Penn State to be the hub that builds up this new workforce and then connects them all to work together around the world to address this problem. We're going to do more than just radio and laser. We're starting with radio, moving into laser, and then we're going to go beyond. But most importantly, we're going to have a steady stream of discovery. When you go looking for the unexpected, you often find it. And that's definitely been true when we found that very strange star that I mentioned earlier, the most mysterious star in the galaxy. It has turned out to be a fantastically interesting puzzle. We still don't really know what's going on. And I still study that star, trying to figure it out, even though we know it's not aliens. So that's why so many of these luminaries have signed on to this vision and are supporting us with NASA and with private fundraising as well. If you want to learn more about this, I encourage you to go to our website. I think that's been communicated to you. It's pseti.psu.edu. There is a video on the support page that Penn State made about this project. And it was great making that video because I got to talk to Frank Drake. Here we are sitting in his backyard, just talking about stuff. The video is also narrated by Jonathan Frakes from Star Trek, which was also very cool. I encourage you to watch that. And then you can also keep track of all of our research and more about the SETI Center on the other side of the page under Research and Media. So that is the SETI Center, and I'm happy to take questions.
All right, excellent, Jason. If you have a question for Jason, you could drop those in the Q&A tab, and we will get to as many of those as we possibly can. You answered my first question there. I think I was going to ask Star Wars or Star Trek. And because you have the narrator from Star Trek, I'm going to assume that you're on maybe that side of the ledger.
I love Star Trek Next Generation. I also like the new Star Wars movies.
Yeah. Jason, let me ask this. And I asked the first question a little bit tongue in cheek, but there is, I mean, the more you talk about this and the more that I learn about your program, the more I realize that there is some solid real science behind this, right?
Right.
And yet there's a perception out there, right? You probably face stereotypes of people who maybe scoff at the work that you're doing. So talk a little bit about how you confound the work that you're doing with some of the public perceptions, especially at the congressional and political levels.
Yeah, there's always been this persistent conflation of what we do with ufology or UFO studies.
Yeah.
And or even worse with, just silly, campy kind of science fiction stuff, like, we're looking for little green men and Martians and all of that stuff. And, I love science fiction and reading that stuff for sure. But, that stuff's written to be fun to read and interesting and about people. It's not written to be a serious discussion about what it might be like. Contact is still the best book or film about what it might actually be like. And so, yeah, sometimes we call this the giggle factor, that we say, oh, we do SETI, and people kind of snicker and they're like, oh, right, like UFOs and stuff. But that's not what we're doing. And so that is a perception that we have to combat. I think we've done a good job of educating Congress about what we are and are not doing. We still have to work on that in the public. And we've also had a lot of trouble with the yellow press, especially the British tabloids. Whenever we do anything, they love to write it up as if we're looking for bug-eyed aliens, and they have pictures of bug-eyed aliens, and they have all these sci-fi references. And so that definitely doesn't help. But we're learning to manage that. And so all we can do is keep doing good science and explaining what we're doing and talking about the real science behind the whole thing.
Can you, so you talked about listening to radio waves. You've talked about using telescopes, powerful telescopes, to look into the beyond. And then there's we all know about the shuttle program and travel through space. What do you think is the most effective method to searching for extraterrestrial life, or is the answer to that question do everything and hope that one of them works, right?
Yeah, I try to keep an open mind, because I have my personal opinions about what we're most likely to find, but they're almost certainly wrong, because how would I know?
Right.
And so I try to keep an open mind. There are things that I don't think are necessarily that worthwhile looking for, but if other people think they're good ideas, I think we should support those. So I also tend to look for things that I understand and I know more about. So I've done more work with stars and planets, and I tended to explore things like, if there's technology around another star and they want to use a lot of energy, they may collect lots of energy from their star, and that would be something we could detect, massive energy collection. And so that's the kind of thing I look for, because I know how and not many other people do it. But the other advantage to that is they don't need to be trying to communicate with us. Like, we'll just notice them because of what they're passively doing. We don't have to assume that they're trying to get our attention. On the other hand, if they are trying to get our attention, that'll be much easier to see because they're trying to get our attention. It'll also be much more unambiguous. Like, when you see that there's a radio signal coming from another star, you're done. There's no ambiguity. You've found alien life. So the different approaches have different merits, and I think we should explore them all.
I mentioned the use of telescopes. What does the loss of Arecibo and how does that affect SETI?
Yeah, that's just so tragic that we've lost that telescope. It was such a workhorse. Frank Drake himself was one of the pioneers on that telescope, and was in charge of it for a long time. It's so sad that it's fallen apart. I really hope we can rebuild it in some way. It was also a workhorse instrument for the search for extraterrestrial intelligence. In the dark days, when there wasn't a lot of funding to get time on telescopes, the SETI Institute and researchers at UC Berkeley had this great idea that if they decided not to be picky about which stars they were looking at, because remember, they didn't know which stars might have planets, that they could piggyback on the other science happening. And they built their own instrument at Arecibo that collected radio waves independently of whatever the other astronomers were doing. And so when some astronomers were looking at something with that telescope, they had their own instrument that was looking at something slightly different the whole time. And so they got 100% of the time on the telescope. They were constantly using the telescope to do this search. They just didn't get to choose what they pointed at. And now we can't do that anymore because the telescope has completely been destroyed. So that's a big loss for the field. Fortunately, there are other instruments we can use. The Allen Telescope Array in California is getting a big upgrade. We're starting to do the Breakthrough Listen project at Berkeley uses what's now the largest telescope in the United States, the Green Bank telescope, as well as telescopes in Australia and South Africa. There's a giant telescope in China that will start to join soon. So it will be replaced, but it'd be nice if we had that back. That was just such a tragedy.
So we have I think we have a thought of what you mean when we talk about life, right? Biological life. But your center is named, it's the search for extraterrestrial intelligence.
Right.
Is there a difference between life and intelligence, or are they synonymous? Are
Oh,
you
no.
looking for carbon-based life forms, or
So no, right. So there is a big difference. When NASA talks about astrobiology and talks about how it's looking for life in the universe, what they mean is we're looking at other places in the solar system for signs that they might once have had life as we know it.
right.
They're looking basically for carbon-based life, not necessarily. They're looking for extinct microbes, for instance, on Mars. They're looking for maybe living, species of some kind in the oceans underneath the ice of Enceladus in Europa. And you have to assume something about life. Carbon-based is usually what they do, not always. But they're not looking for anything that could build technology. They're not looking for anything you could talk to. And on a place like Mars, they're not even necessarily looking for anything that's still there. It could be fossil, although that would be much harder to find. When we talk about the search for intelligent life, what we really mean is technological life. Life that could do something with technology so obvious that we could see it at interstellar distances. And so that's a very different kind of search, and that's what it is that NASA has not been doing. So we're looking for kind of the other end of the scale. When Earth was young, there was just the kind of microbial life that we think we're looking for elsewhere. We're looking for complex life that builds technology, whatever that means, and it definitely doesn't have to be carbon-based.
So a question that came in is, how do you reconcile Fermi's paradox?
Yeah, Fermi's paradox. So Fermi's paradox is older than the field of SETI. The idea is that the Nobel Prize-winning physicist Enrico Fermi was having lunch one day, and they were talking about the possibility of alien life, technological alien life. And he said, so where is everybody? And what he meant was that at the time in the 1950s, rocketry was young, but it was pretty clear that you could build rockets that, had given enough time, could go to another star. So the universe has been around for billions, over 10 billion years. They've had plenty of time to fly all over the galaxy. And, why aren't they here? Where is everybody? Why does the galaxy look like it's empty? Now, I would argue it doesn't really look empty. It's very hard to see technology at interstellar distances. We haven't really looked very hard. We haven't had funding to. But that's the essence of the Fermi paradox. If the universe is filled with aliens, where is everybody? And I would say, I don't know, because we haven't looked.
So again, some of these questions I'm just going to ask you as the way they're coming in, because they're maybe beyond my understanding. But
Sure.
Could there be intelligent life hiding in other string theory dimensions?
I don't know, and I have no idea how we'd go about looking for it.
Okay.
Maybe? I don't know.
You mentioned that you're exploring technologies beyond electromagnetic transmissions. What are some examples of that?
Yeah. So there are four fundamental forces that govern the universe. There's electromagnetism, and that's the one we almost always interact with. It's the reason you can touch solid objects. It's because electromagnetic forces between your hand and the object stop them from just melding right together. It also governs all light. So everything you see, everything you touch, everything you feel that governs your body, that's electromagnetism. And then there's three others that don't come up all that often. There's the weak force, which governs these particles called neutrinos. And they generally only happen in nuclear reactions that you get these neutrinos, and they pass right through the Earth without touching anything. So they're almost impossible to detect. But they don't always pass through. Sometimes they'll get lucky and hit an atomic nucleus and cause a little nuclear reaction. Very tiny, barely any energy. But that can create a flash. And they're super rare, but we now have giant telescopes deep in the Antarctic ice and in mines and things like that can actually detect it when that happens. And so we can detect these nuclear reactions happening all over the universe now. Gravitational waves are only emitted when masses move, and they have to be very big masses. Like when stars are whipping around each other or get eaten by a black hole, that will give off gravitational waves. And then the strong nuclear force governs how atomic nuclei stick together. And so if you have some sort of event in space that accelerates things, you end up with these atomic nuclei flying through space. So when atomic nuclei hit the Earth's atmosphere, when gravitational waves pass through the Earth, when neutrinos pass through the Earth, we can now study all of those things. And so people have asked, even before we could detect those things, might alien technology be doing things on massive scales with huge amounts of energy or huge amounts of mass, big engineering projects that would generate neutrinos or gravitational waves or cosmic rays, these nuclei? And it's always just been speculation. Yeah, sure, maybe, but how would we know? We can't detect them. Now we can detect all three of those things. And so now people are starting to say, well, let's go look, let's go see if we can find anything. And Penn State is one of the only places that does all of those things at once.
From what I understand about your work, we're getting some questions in about some other planets that are in our solar system, but you're specifically focused on beyond that, right? You're looking.
No, not
Go ahead.
necessarily. I mean, a lot of and part of Fermi's paradox is, why aren't they here? Like, you can do interstellar travel, and so people have asked, why aren't they here? And it wasn't that long ago that astronomers totally entertained the possibility that there might be intelligent life on Mars. Now, when the Mariner probes of the 70s went to Mars and took pictures of it, there weren't big canals, there weren't farms, there weren't cities and stuff. It became clear that Mars was a desert and not the kind of place where you'd expect to see lots of life. And so we kind of stopped thinking about there being life, intelligent life, in the solar system. And then we explored all the other planets and moons, and it doesn't look like there's cities. It looks like Earth is the only planet with life, much less technological life. On the other hand, it's possible that they've sent probes that visit. It's possible that there are things in the solar system that are artificial, that were left here from a long time ago. And so people talk about, looking at the asteroids and seeing if any of them have been mined, seeing if there might be stuff on their surfaces, seeing if there might be things on the other planets. This does get a little dicey because this is a common trope in science fiction. And so there was the whole nonsense in the tabloids about the face on Mars, for instance. And so the field kind of has a bad name, but it's a serious question. Can we be sure there aren't any probes in the solar system? Is there a way we could look and rule that out? And so far, we haven't really done much to rule it out. So yeah, we can definitely do SETI in the solar system.
So a question coming in, if you find intelligent extraterrestrial life that sent a message, we would probably be unable to communicate since the distances are so vast, and probably the message was sent hundreds or millions of years ago. Is that right? Or is that maybe not? Go ahead.
Yeah, so depending on how far away the message came from, it might only be a few years old. The nearest stars are just a few light years away. And in fact, where we spend most of our time looking for technological life is the nearest stars. So it wouldn't necessarily be millions of years old. It could just be 10 or 20 years old. But yes, when we get the signal, we don't have any reason to think we could decode it. Now, if it's meant for us, if they're sending a signal that's supposed to be interpreted, it's possible that they have figured out some way to cross all of the language and cognitive barriers that separate us as different species to tell us something we know. Well, that's hard. We don't know how to do that. So we know there are other communicating species on Earth. We know that, dolphins can communicate, for instance, and yet we can't figure out what they're saying. And we can study them as closely as we like. We have no idea what they're saying, not in terms of a grammar and things like that. So it'll be very hard to do interspecies communication, but maybe they've solved that problem and they're sending a signal that we're supposed to understand. That's what happens in contact, for instance. That's possible. But especially if it's not meant for us, if we're just intercepting a message that's passing by, it seems very unlikely we'd be able to decode it, to me. But then I'm just guessing. I don't know. We need to look and see.
Yeah. So you've talked about the work of your center as solving a problem, right?
Yeah.
Or answering a question.
Yeah.
When the question's answered or when the problem's solved, what's next?
What's next? Right. Well, I mean, it's the search for extraterrestrial intelligence.
Right.
And the nice thing is that once we find it, we don't have to change the acronym because we'll just become the study of extraterrestrial intelligence. But what usually happens in SETI or in science is that when you finally answer that big question, you realize that there are questions you didn't even know you needed to ask. And so it's amazing to watch the march of science, not as things we've learned, but as new questions we've learned to ask. Because you can't answer a question until you know you don't know the answer.
Yeah. So a couple questions coming in. Do you ever enlist private citizens for research, and does work by the folks in the 50s and 60s help? Can PSU retirees visit Swift Lab? So first things first, do you ever enlist private citizens for help, and
Absolutely.
are the labs open?
So private citizens, so we call it citizen science or community science, where everyone in the world can help. And this was actually the big problem when they had the data at the Arecibo telescope, because they were collecting data from the telescope 24 hours a day, 7 days a week. It was a huge amount of data, and UC Berkeley did not have enough computing power to analyze it. Mm-hmm. And so Dave Anderson and others at UC Berkeley had this great idea that everyone is just wasting their computers. You remember old computers with the monitors, the CRT monitors, you had to have a screensaver, or you would burn in the image on your monitor. And so when your computer went idle, you'd get that thing that bounced around. And they said, what a waste of computer power. They should be analyzing our data. And so they invented SETI at home, which was a screensaver that downloaded the data and showed you the data. And that's what your computer would do when it was idle. And it was fantastic. It was the largest distributed computing project in the world. It spawned lots of other projects like Einstein at home and protein folding at home. And in fact, it became the basis for things even like Bitcoin, to use everybody's computers to solve these problems. So that's one example where SETI has actually made a really big impact on the world. You can still get SETI at home, and now you'll analyze data from the Green Bank telescope with it. And you can also participate in other ways. There's Zooniverse, which is a website where you can participate in lots of different science projects to do all kinds of different things, including lots in astronomy. And we have a proposal in right now with the National Science Foundation to add one to work with the search for extraterrestrial intelligence. And finally, I'd say that really weird star we found, I didn't find it. No astronomer found it. That was found by a citizen scientist on Zooniverse who was looking for planets and said, oh my gosh, what is that? And we still don't know the answer to that question. So yes, lots of ways to get involved. Start with Zooniverse and study at home.
And if alumni are tuning in today and people are interested, how can they support the work that you do?
Right. I forgot to say, can you visit the lab? Yes, we have open houses at Penn State. You can come and use the telescopes on the roof. We have Astrofest during Arts Fest. So if you're in town for Arts Fest, definitely come. And then on Parents Weekend, we do Astronomy. And you can visit the department then for sure. And when things are open, you can also call the front office and ask if there's any way you can get a tour or something. And then people want to know more, definitely go to the website pseti.psu.edu, which I showed. Please watch that very cool video. It's just brilliant. And you can follow along on the other side of that page under research and media to learn more about what we're doing and see as new things come up. Also, you can follow us on Twitter. The PSETI Center has a Twitter account, and that will tweet out all the research we do as well.
That is great. Well, Jason, we want to thank you for joining us on the virtual speaker series today. It was a great presentation and certainly giving us something to think about. So we're so grateful for all the work that you're doing here at Penn State.
Great. It was great to be here. Thank you.
And I want to thank everybody for Zooming in today. There are links in the chat if you are interested in finding out more information about more information about SETI or how you can support SETI. Check those links out. As a reminder, we'll be hosting additional virtual speaker sessions and virtual programs over the coming weeks and months. You can find all of that information on our website at alumni.psu.edu. Thanks again, and we are
Penn State.